Good afternoon. Sorry, good evening, everyone. So, আচ্ছা আমি তোদেরকে দুটো কোশ্চেন দিয়েছিলাম না as a homework. So I start from that homework. I think the question number 1. One concave mirror and a plane mirror. The separation between them is 22.5 centimeter. The focal length of concave mirror is minus 10 centimeter. The question is that where we place an object in between that so that the image of both the mirror coincide. Let that is by the plane mirror and that deep line by the curved surface. So for that, let that distance is x. So obviously that distance is 22.5 minus x, and object distance equals to image distance 22.5 minus x. So from 1 by v plus 1 by u is 1 by f. These all are in front. So 22.5 and 22.5, 45 minus x in front plus minus x equals to minus 10. So minus cancel. So what we have, 45 minus x, 45 minus x is 1 by 10. Sorry, x plus 45 minus x. So this cancel. So what you have, 45x minus x square is 450. So which means x square minus 45x plus 450 equals to 0. So when you x square minus 30x minus 15x plus 450 equals to 0. X minus 30 minus 15x minus 30 equals to 0. So x minus 30, x minus 15 is 0, which means x equals to 15 or 30 centimeter. Now see, 30 centimeter is not in between this, so this is not the answer. So the answer is 15 centimeter. Is it okay, everyone?
Yes, sir.
Now the second question. If you see the second question, in the second question, you have two curved surface or two curved mirror. One is the concave, one is the convex. And what is the separation between them? According to this, according to the question, the separation between them is 40 centimeter. The focal length of concave minus 10 centimeter and focal length of convex plus 15 centimeter. It is given, and the object is placed 15 centimeter from the concave mirror. And the question is that two successive collision, first at concave, then at convex. Okay, you have to say or mention the size, position, nature of the image. So this is my overall question. So we can suppose this one is a first, this one is a second. So in that case, uh, 1 by V1 plus 1 by U1 is 1 by F1, and obviously ray is moving like this, and then it's or you can say in that way, suppose this is the object, so ray is moving like this. Okay, so what we can say, 1 by V1 plus minus 15 equals to 1 by minus 10, from 1 by V1 is equals to minus 1 by 10 plus 1 by 15, that is 30, minus 3 plus 2 minus 1 by 30. V1 is minus 30 centimeter. So minus 30, so that means the almost the image is here, which is 30 centimeter in that side. So let it be P1. Now for the second case, as this is the P2, so we have to measure this distance, and now images behave like an object, so ray is coming in this direction. So in that case, now the total distance is 40, this is 30 centimeter, so obviously u2 is 10 centimeter, and this is the coming ray, and you have to move in that direction. So in the second case, your u2 is positive, so your u2 is minus 10 centimeter. So U2 is minus 10 centimeter. What about V2? You have to find out. So 1 by V2 plus 1 by U2 is 1 by F2. V2 you don't know, U2 is minus 10 and F2 is plus 15. So from that, 1 by V2, 1 by 15 plus 1 by 10, that is 30, 2 plus 3. So 1 by V2 is 5 by 30. So V2 is plus 6 centimeter. What do you mean by plus 6? That is in this direction and inverted, erect with respect to I1. So that one you can say V2. So obviously one thing we can say now, that the image is, final image is virtual because it is inside the mirror. Now overall magnification, that is magnification by the first mirror and magnification by the second mirror. So minus V1 by U1 into minus V2 by U2. So minus V1, V1 is minus 30, U1 is minus 15 into minus V2. V2 is 6 and U2 is minus 10. So what you have, minus minus cancel, 2, this is 3, this is 5. So minus minus plus, overall minus 6 by 5. So overall, as the magnification is greater than 1, so you can say overall the image is magnified. Now as you have minus, that means overall the image is inverted. See, first time it's inverted, then it is erect. So overall it is inverted, and as it is inside the mirror, so it is virtual. So what is your final statement? The final image is inverted, virtual, magnified 6 by 5 times, and virtual 6 centimeter behind the mirror. Is it okay, everyone? You understand what is the statement?
Yes, sir.
Okay, so that's all for mirror, means reflection. And now we move on to our next topic, which is refraction, which is today's topic, refraction. So in refraction, first of all, what do you mean by refraction, or what refraction is? What? So when ray travel from one medium to another medium, when ray travel from one medium to another medium, so the light bend means it's not move in the same direction, either it's move towards or it move away from the normal. so that ray is divert. That phenomena is called refraction. So what do you mean by refraction? Refraction is the phenomena due to which when ray travel from refractive index 1, refractive index 2, when ray travel from one medium to another medium, this is the actual ray, either it is move in this direction or it is move in this direction. The as it move from or bifurcate or change from its original path, that phenomena is called refraction. Is it okay, everyone?
Yes, sir.
Yes, sir.
This is the incident ray, and if this is the refracted ray, if it is moved towards the normal, that means N2 is greater than N1. And if it is moving away from the normal, N2 is less than N1. That means if the ray travel from the higher refractive index to lower refractive index, it is moving away. If the ray travel from lower refractive index to higher refractive index, it is moving towards the normal. Achha, now the most important thing is laws of refraction. So what do you mean by the laws of refraction? First law is laws of refraction. First law is, I think all of you know that incident ray, refracted ray, and normal, they are in the incident ray, refracted ray, and normal. Incident ray, refracted ray, and normal, they all are in the same line, that we all know. So this is the first law. Now the second law is that, actually what happened, when ray travel from one medium to another medium, its refractive index and sine of the angle for any medium is remain constant. So sine of the angle is remain constant. That means here what happened for the first medium, if we write N1 sine I, for the second medium N2 sine R. First medium into the angle of incident, second medium into angle of this are constant. So from that actually we can say sine I by sine R, that is N2 by N1, which is called the Snell's law. So Snell derived this law actually from the phenomena this one. Okay, so what is the Snell's law? Snell's law is that the ratio of incident ray by refracted ray is equals to inverse of refractive index of N2 by N1. That is called the Snell's law. But it is better you remember in that manner. If you able to remember in that manner, it will help you in so many form. Okay, we discussed some numerical also. That is the second part. The third part of laws of refraction, which you don't have in class 10, okay, because in 12 they never ask you laws of refraction, but they ask you the applications of laws of refraction, where you apply these things. Okay, so the third part is, which is very, very important. The third part for laws of refraction is very, very important, is when we travel from one medium to another medium, try to understand, when we travel from one medium to another medium, velocity of light, when they travel from one medium to another medium, velocity of light, comma, wavelength changes. So when they travel from one medium to another medium, velocity of light and wavelength changes, comma, but frequency and phase angle remain constant. So these are very, very important. These two remain constant and these two are variable. And you can correlate them like velocity of light is equals to wavelength into friction. into frequency. This important. This is very, very important. So how they give you question? How they give you question? They give you like they can give you suppose for air wavelength is 5000 angstrom. What is the frequency? Frequency. This is the first part, which we know. This equation we know from electromagnetic wave also. Light is also electromagnetic wave. What is the frequency? Now the second part is that if it enters in water, refractive index 4/3, find wavelength, velocity of light, and frequency. So now they give you a little bit what you can say twist. Okay, so don't kabhi ghabrao mat. Okay, so when they give you this type of question, first of all, find the frequency. We know the relation C equals to F lambda, yeah, lambda F. So 3 into 10 to the power 8, wavelength 5000 means 5000 into 10 to the power minus 10 into minus 10 into F. So 5 into 10 to the power minus 7 into frequency. So frequency is 3 into 10 to the power 8 by 5 into 10 to the power minus 7. That is 3 by 5 into 10 to the power 15. That is 0.6 into 10 to the power 15. That is 6 into 10 to the power 14 hertz. So this is the answer for the first part. This is the answer for the first part, frequency. Now they ask you, if it enter into water of refractive index 4/3, what is the wavelength? So see, wavelength in the medium like water, when you put any medium, wavelength in air by refractive index of that medium. Hope you understand how you find out the wavelength of a medium. Wavelength of a medium, that means wavelength in air upon the refractive index. Is it okay? Everyone,
Yes,
is it
sir.
okay? Am I audible properly?
Yes, sir.
And if you have any doubt, you can tell me, okay?
Yes, sir.
As it's a virtual class, even I am not able to see you. So in air, it is 5 into 5000 angstrom, you can write, and that is 4/3, I'm sorry, 4/3. So 15 by 4, this much, you can calculate it. जो भी हो आ जाएगा कुछ. हाँ 5 10 15, हाँ, you can calculate it. Now they if they ask you velocity of light in that medium, that means the medium is water. We all know velocity of light by again refractive index. So what we can write, 3 into 10 to the power 3 into 10 to the power 8 by 4/3 again. So 9 by 8 into 10 to the power 8 meter per second. You can again calculate this. Sorry, 4 na. So that is charger at 2.25 into 10 to the power 8 meter per second. If we use water, is it clear, everyone? And if they ask you frequency, frequency remains same without the second thought. You can write. Am I clear? If you see the equation, if the C increase, lambda increase. If the C decrease, lambda decrease. So I think you can understand. Is it clear?
Yes,
Everyone,
sir.
is it clear? So after that, if you understand that part, okay. Next part is next thing is write down absolute refractive index and relative refractive index. What is the basic difference? See, the absolute refractive index means refractive index of any medium, refractive index of any medium with respect to air. As with respect to air, That means light travel from air to that medium. Suppose I'm writing here a refractive index of water, refractive index of glass. That means automatically I put air is the first medium. So, so these are the absolute refractive index, means refractive index of water with respect to air, refractive index of glass with respect to air. So 4 by 3 by 1, 3 by 2 by 1. So that is 4 by 3, that is 3 by 2. But if I say refractive index of air with respect to water, if I say the refractive index of air with respect to water, that is not absolute. See, if I write refractive index of air with respect to water, refractive index of air with respect to glass, then what happened? Then glass is the first medium, air is the second medium. You always remember, you have to remember this side is the second medium. So air with respect to water, air with respect to glass. So now it is 4 by 3. So 3 by 4, 3 by 2. So it is 2 by 3. See, one thing that the basic difference is that absolute refractive index means whenever it is compared to 1, means air, the absolute refractive index always greater than 1. But relative refractive index means between the two medium, any two medium, it can be air also, any two medium, when you compare, the relative refractive index can be greater than 1, can be less than 1. Like see, refractive index of air with respect to water less than 1. Refractive index of glass with air with respect to glass is 2 by 3. Now if you see the, suppose not only this one, refractive index of glass with respect to water, refractive index of water with respect to glass, if we compare, then now we remove the air, we enter, we have to compare them glass with respect to water. So glass with respect to water, so water is the first medium, glass is the second medium. With respect to matlab pehla, glass with respect to air, matlab air is the first medium. So here glass with respect to water. Now water with respect to glass. See, so glass with respect to water, 3 by 2, 4 by 3. So what you have, 9 by 8, 4 by 3, 3 by 2, you have 8 by 9. So what we realize, see, the relative refractive index can be greater than 1, relative refractive index can be less than 1. But absolute refractive index means any refractive index with respect to air is always greater than 1, and that's why air we suppose 1 and we compare with that with respect to that. Okay, and in that air is actually pure air, means where you can actually say the vacuum is the perfect answer, but we almost calculate air is also like vacuum, not exactly but almost. In generalized form we use, it is not possible if we see the light in vacuum and we observe it, because we are not able to alive there. Okay, uh, up to this, is it okay everyone, students?
Yes, sir.
Okay, now suppose we have so many medium, like first medium, second medium, third medium, fourth medium, and fifth medium. So suppose this is the first medium. Light is travel from one medium to another medium, then this one, then this one, then this one, and then this one. I'm just give it randomly. So now anyone can ask you refractive index of fifth medium with respect to first medium. So what do you mean by that? Refractive index of 5 with respect to 4, refractive index of 4 with respect to 3, refractive index of 3 with respect to 2, 2 with respect to 1. So what do you mean by that? If you see this, these all are cancel each other. So you have 5 with respect to 1. So basically, relative refractive index always depends on the last medium and the first medium. Now, if you want to change, the first medium and last medium are same. So then what happens? See, Suppose this is the original, right? And if you say N5 and N1 are equal, any two medium, suppose you equal. So relative refractive index is 1. What do you mean by that? Now the in that means first and last move parallel. So whenever if two refractive index are of same, so the light is moving parallel. What do you mean by parallel? They are not diverted. Okay, and that's why you can say if you emerge a glass slab, suppose if you emerge glass slab in glycerin, what happened? Glycerin glass slab disappear. When you emerge glass slab in glycerin, glass slab disappear. Examiner ask you justify your answer or why it is happened. So what is your answer? Tell me. Anyone? Why this happened? When we put
Equal refractive index.
yes. So as they have the same refractive index, so the light is moving in a straight line. It's not able to divert, means bifurcate, means जो जा रहा है उसी पाथ में जाएगा, वो बेंड नहीं होगा. और जब तक लाइट एक जगह से दूसरी जगह में बेंड नहीं होता है, हमें लाइट दिखाई नहीं पड़ेगा. हम लोग को इसको सब सेम मीडियम लगेगा, अलग अलग मीडियम लगेगा अगर लाइट बार बार बेंड हो. लेकिन अगर हम सेम मीडियम इसको कर दे तो लाइट बेंड नहीं होगा, हमें पता नहीं चलेगा कौन सा लेयर कौन सा है. Is it okay? So that's why what happened, that means the refractive index of glycerin and refractive index of glass are the same refractive index. Because of that the glass will disappear. अच्छा, this ये जो पहले से जो इधर आ गया है, that is called the lateral shift. Okay, that is called the lateral shift, which is in your syllabus. So my next heading is lateral shift. My next heading is lateral shift. So देखो lateral shift में क्या होगा. Suppose we have a glass slab. T is the thickness. अच्छा, यहाँ पे एक रे है, हमें यहाँ से एक रे को ऐसे करके लिया, ये आया और ये इसका पैरेलल जाएगा. देखो मैं एक कुछ बात बताना चाहता हूं कि these two ray are parallel. These two ray are parallel only when they are parallel. मतलब you don't understand what I want to say. Suppose same question में अगर मेरा लाइट यहाँ से आया और ये मानो यहाँ पे गया, ऐसा भी हो सकता है कि ये यहाँ से टोटल इंटरनल रिफ्लेक्शन हो जाए. सो यहाँ पे ये कभी भी पैरेलल नहीं होगा, लेकिन यहाँ पे ये पैरेलल होगा. इसका मतलब कैसे? देखो ये जो कॉर्नर फॉर्म हो रहा है ये एक्चुअली है एंगल ऑफ प्रिज्म. देखो ये देखने में एक प्रिज्म जैसा दिख रहा है ना. सो अगर हम एंगल ऑफ प्रिज्म को ऐसे कर दे, so what is the angle of prism is 180 degree. Is it clear?
Yes, sir.
So if the angle of prism is 180 degree, that means they are parallel. They must be parallel. Parallel होगा तभी होगा. ऐसा नहीं है कि एयर ग्लास स्लैब फिर एयर तो पैरेलल हो जाएगा, नहीं. उसके साथ ये कंडीशन है कि ये जो है ऐसा नहीं होना चाहिए, ये पैरेलल होगा. अगर ये पैरेलल होगा then and only then, माने 180 डिग्री होगा, then and only then the incident ray and the emergent ray are parallel, and then this is called the shift. तो हम इसको लिखने का जरूरत नहीं है, तुम्हें ये है, जस्ट ये बता दिया. So this is the incident ray, this is R. You can say this angle is I minus R. We can name it A, B, C, D. Let it be E. And let it be N. And this is the refractive index. The value is, suppose N is the refractive index. So ये मान लिया 1. So now, first of all, from the triangle BCE, BCE, sine I minus R, sine I minus R. What do you mean by this? Perpendicular by hypotenuse. So we write CE by BC. Now CE is the separation depth or shift, D lateral shift. So D by BC. So D is BC sine I minus 1. Let it be the equation number 1. Now in triangle BNC, now in triangle BNC, cos R is base upon hypotenuse. So base upon hypotenuse, BN by BC. So we need BC. BC is cos R by BN, that is T. So if we put this equation 2 in equation 1, so D is equals to cos R by is it okay? Now ulta likha na, sorry. BC is BN by cos R, which is T by cos R. I'm sorry. So D is equals to, in place of BC, we can write T by cos R, and this one is sine I minus R. So this one is your lateral shift. This one is your lateral shift. T is the thickness, sine I minus R by cos R. Is it okay, everyone?
Yes, sir.
So examiner simply give you the thickness. Examiner simply give you the refractive index. You can, they give you the incident ray with respect to that, 1 into sine I, n into sine R. So you can get the value of R. When you get the value of R, you know the value of I minus R, you get the value of sine I minus R, you have cos R. You can find out the shift. That is the first thing. Second thing is that sometime important note, if angles are very small, this is up to 10 degree, not more than 10 degree. If the angles are very, very small, so we all know when the angle is very small, sine theta nearly equals to tan theta, nearly equals to theta, and cos theta nearly equals to 1. Is it okay? We all know this from long time. Okay. Even whenever the theta is very small, sine theta is tan theta equals to theta, cos theta nearly equals to 1. Even from that parallax method and all. Acha. So now, as the angle is very small, because in light, most of cases, so many cases you get where the angle is very small. So D is T sine I minus R, because sine theta by cos theta, or cos theta is 1. So cos R is 1. So you have T I minus 1 R. And now from laws of refraction, 1 into sine I, n into sine R. So due to small angle R, so R is I by n. So if we put it here, so D is T I minus I by n, which is T1 minus y by n, 1 by n, I is the D. So D is T within bracket 1 minus 1 by n I. Is it clear? Now again, they
Sir.
can give you the refractive index, they can give you the incident angle. Suppose the incident angle is 4 degree. They give you the refractive index thickness. You can easily find out the shift. Acha. Is it clear, everyone?
Yes, sir.
Okay. So after that, the next part, next very, very important part is real depth and apparent depth. The next very, very important part is real depth and apparent depth. So in case of real depth and apparent depth, you have two type of situation. So real real depth, তুমি কি সাতটাতেও পারবে না, and apparent. So two cases are there, or you can say two possibilities are there. Case one, the possibilities are where you put the object and where is the observer, means viewer. So case one, suppose we put the observer in the denser medium and viewer at the rarer medium. So suppose this is the observer and this is the denser medium. Okay, so observer is at the denser medium. So what happened, from the observer, ray is coming like this. Now the ray travel from denser medium to rarer medium. It is moving away from the normal. If anyone see it from outside, it appears like this. So we can say OAB, we can say N. This angle is the incident angle. So this angle is I. This is the refracted ray. So this is R. Achha. Again, you have some conditions. Conditions are that, first of all, don't see it from exactly vertical position. If you see it from the vertical position, you can see the actual depth, means the T. You can see the actual depth. So to see it, how much it shift upward, you have to see it from a little bit bending angle, means not exactly vertically, but a little bit make an angle, but don't make it so much angle, large angle. If you make it so much large angle, so then what happened with respect to that vertical shift, there is a horizontal shift. मतलब actually क्या होगा, अगर हम ज्यादा एंगल में देखेंगे तो ये ऐसा जगह पे आ जाएगा, मतलब वर्टिकल के साथ साथ हॉरिजॉन्टल शिफ्ट भी होगा, विच इज नॉट इन योर सिलेबस. ठीक है, तब साइन वगैरह लेके करना पड़ता है, वो सिलेबस में तुम्हारा नहीं है. तुम्हारा सिलेबस में सिर्फ है फॉर द वेरी स्मॉल एंगल. तो मैं पहले ही बोल देता हूं, एंगल्स आर वेरी स्मॉल, बट नॉट फ्रॉम द वर्टिकल. ओके, अब देखो, वी कैन यूज लॉज ऑफ रिफ्रैक्शन फ्रॉम laws of refraction. First medium into sin I, second medium into sin R. Now due to very small angle, due to very small angle, ni is R. We can write, because theta is nearly equals to sin theta, nearly equals to tan theta, cos theta nearly equals to 1. Same thing repeatedly. Now due to this small angle, I nearly equals to tan I, nearly equals to perpendicular by base. So this is perpendicular, this is base. So we can write Na by R, we can write tan R, we can write perpendicular by base, that is Na by Ni. So if we put it here, so what happened, N into Na by No, that is Na by Ni, N cancel. So Ni, that is No by N. What do you mean by real depth? No is T, so you can write T by N. So now what we can say, real depth, which is the real depth, which is No. How much? T. Now this is the actual depth and you appear it here. So apparent depth, Ni, this one, which is T by N. T by N. Now the third one is how much it shift from O to I. So apparent shift. So T1 minus 1 by N. So hope you understand that part. Is it okay, everyone?
Yes, sir.
Everyone, you understand that part? Hello.
Yes, sir.
So if you understand that part, the second part is if the what happened if the object is at rarer medium and viewer at denser medium. First I give you that example. See this one, this type of situation means, suppose you think in that way ki a fish observing a kingfisher. I'm sorry, a kingfisher observing a fish. So kingfisher observing, so kingfisher is at the rarer medium and fish is at the denser medium. So kingfisher observing, the observer is kingfisher and object is fish. Now the reverse thing also happened, ki a fish observing a kingfisher. So if the fish is observing a kingfisher, now the fish means observer is at denser medium and kingfisher is at rarer medium. So let's see what happened in the second case. Case 2. Suppose this is the object. The ray is coming like that, very small angle. Now when the rays travel from rarer to denser, it is moved towards the normal. So if you move it, it appear little bit upward, means I. So this angle is R, this angle is I, this angle is I, this angle is R, this angle is R. So let it be OAB, this is N, refractive index is N. Now see, observer is on the rarer medium and viewer who is viewing it, they are on the denser medium. So now what happened? Again, we can use the laws of refraction. Laws of refraction. That formula is very, very important, n into sine theta. And after that, I show you one question, which I forget to show you. How you using that formula n into sine theta, you can solve numerical in a fraction of second. So the laws of refraction, first medium is 1 angle of incident sine I n into sine r. So again the angle for very small angle I equals to nr. Now I nearly equals to 10I is perpendicular by base. So na by no r 10r na by ni. So na by no. Acha, let this height is the h. Na by no, that is n into na by ni. So na cancel. So ni is n into no, that is n into h. So real height is h, apparent height is nh, and shift is nh minus 1. If you want, you can write on, you can write oi, you can write ni no oi. But how you remember that? The best process is that to remember them. The best process is that if the observer at rarer medium, object is at denser medium, so whatever be the depth by mu means t by mu, and if the observer is at rarer medium and viewer at denser medium, ये ऊपर उठ जाएगा, मतलब into n means x y z whatever be the height into n. और जब डेप्थ में है मतलब डेंसर मीडियम में है observer तो by n. So this is the basic difference. And now I show you some numerical related to that. They are very, very interesting numerical. Before that, I want to show you that question also. 1 marks question, so many times asked in board exam. Suppose they give you like this. This is the incident ray. Suppose 45 degree. 45 degree. 45 degree. And now suppose this one is 30 degree. This one is 35 degree. This one is 60 degree. Let the refractive index of upper one is N1. This is N2. This is N3. This is N4. And they say you arrange them from higher value of refractive index to lower value. देखो कुछ सोचना ही नहीं है, क्या लिखना है, n into sin theta is constant. तो जिसका रिफ्रैक्टिव इंडेक्स ज्यादा होगा उसका क्या होगा, एंगल कम होगा. जितना एंगल कम उतना ज्यादा रिफ्रैक्टिव इंडेक्स, जितना ज्यादा रिफ्रैक्टिव इंडेक्स उतना कम एंगल, जितना कम रिफ्रैक्टिव इंडेक्स उतना ज्यादा एंगल. तो जितना ज्यादा एंगल उतना कम रिफ्रैक्टिव इंडेक्स, जितना कम एंगल उतना ज्यादा रिफ्रैक्टिव इंडेक्स. तो सबसे ज्यादा रिफ्रैक्टिव इंडेक्स किसका होना चाहिए? हेलो हेलो
Sir,
हाँ बोलो बोलो बोलो.
sir, repeat the question.
Whose refractive index is maximum?
The one who has the least angle, minimum angle.
Least angle. Very well, very good. So clearly 30 degree is the minimum angle. So refractive index N2. इसके बाद देखो तो सबसे कम एंगल किसका है? 35. जिसका कम एंगल उसका ज्यादा रिफ्रैक्टिव इंडेक्स. तो सेकंड में 30 N3 है. उसके बाद किसका है? 41 है, 45 है. तो थर्ड में N1 है. सबसे ज्यादा एंगल किसका है? 60. तो सबसे कम रिफ्रैक्टिव इंडेक्स कितना है? N4 का. I think you understand the pattern.
Yes, sir.
So this type of question also sometimes asked. Students are so much confused, किसका ज्यादा है किसका कम है, पूरा कैलकुलेशन करने बैठ जाता है. कोई जरूरी नहीं है कैलकुलेशन करो. सिंपल देखो, जिसका एंगल कम है उसका रिफ्रैक्टिव इंडेक्स ज्यादा है, जिसका एंगल ज्यादा है उसका रिफ्रैक्टिव इंडेक्स कम है. अच्छा, नाउ कम बैक टू द प्रीवियस थ्योरी. एक क्वेश्चन है कि वेरी वेरी गुड क्वेश्चन. एक लेक है, ठीक है, लेक में एक फिश है, which is at a depth of 10 meter from the lake and refractive index of water is 4/3. और इससे ऊपर एक किंग फिशर है. ये है फिश, ये है किंग फिशर. You don't know the height. The question is that fish observe, I repeat, question is that fish observe the kingfisher. Fish observe, हाँ, इसलिए मैं ये लिखा. Fish observe the kingfisher is at a height of 30 meter from the fish. Fish observe kingfisher is at a height of 30 meter from the fish. What is the actual height of the kingfisher from the lake? Means the surface of the lake. तो देखो ऐसा क्वेश्चन में जो ऑब्जर्वर है उसको मानो हम एस मान लिया, ठीक है, और जो ऑब्जर्वर जिस मीडियम में है उस मीडियम को वो वही देखेगा. मतलब अगर हम लोग सब अगर सेम मीडियम में है तो हम दोनों का बीच का जो डिस्टेंस है वो सेम ही रहेगा. लेकिन अगर हम में से कोई एक एयर मीडियम में रहे, कोई एक वाटर मीडियम में रहे, तो अगर मानो मैं वाटर में हूं और तुम लोग एयर में हो, तो मैं जितना वाटर में हूं उतना मीडियम को उतना ही देखूंगा. लेकिन मैं देख रहा हूं तो मैं क्या देखूंगा कि तुम लोग जितना पे हो उससे ज्यादा पे चले जाओगे. सो बेसिकली व्हाट हैपेंड, एस इज जो देख रहा है वो खुद का वही देखेगा और इसको ऊपर में देखेगा, मतलब एनएच. इज इट क्लियर? Everyone, is it clear?
Yes, sir.
Everyone, Akash, Ananya,
Yes, sir.
Dikshita,
Yes, sir.
Rohit,
Yes, sir.
Devojit কোথায় চলে গেল? Oh, Devojit is there. So, is it okay for everyone? So now the fish observe is 30 meter actual distance is 10 meter, n is 4 by 3 into h. So what happened? 4 by 3 into h, 4 by 3 into h is 20. So h is 20 into 3 by 4, which is how much? 15 meter. So this is the actual height is 15 meter. Now we calculate. Now we can ask the reverse question. Ki from Kingfisher, where the Kingfisher observed the fish. Are you getting my point? Where the Kingfisher observed the fish. Are you getting my point?
Yes, sir.
So now, who is the observer?
Kingfisher is the observer.
And who is the object?
Fish is the object.
Yes. So now again we can say S is equals to H. अपना मीडियम को वही देखेगा. अब वो फिश को क्या करेगा? ऊपर देखेगा because fish is in the denser medium. So मुझे क्या लिखना है? X into N या X by N?
X by N.
Very good. X by N. So अब देखो H मुझे पता है 15, X मुझे पता है 10 और N मुझे पता है 4 by 3. So 15 plus 10 into 3 by 4 मतलब 5 by 2. So 15 plus 7.5, that is 22.5 meters. Hope you understand all. Is it okay?
Yes, sir.
अच्छा अब देखो तुम लोगों को एक क्वेश्चन मैं दिखा रहा हूं. दिस क्वेश्चन आस्क्ड वंस इन IIT. ओके, सो यू कैन अंडरस्टैंड व्हाई दिस आर वेरी वेरी इंपॉर्टेंट. ठीक है, कि मैं क्यों पागल जैसा इतना कुछ कराता हूं, कहीं पे तो ये सब कराता ही नहीं है ना, फिर भी सोमनाथ सर पागल जैसा ये सब कराता है. क्यों कराता है? नाउ यू कैन इमेजिन. दिस क्वेश्चन इज बेस्ड ऑन IIT. सो फर्स्ट आई वांट टू read the question. A kingfisher rising vertically, a fish rising vertically to the surface of water in a lake uniformly at the rate of 3 meters per second observes a kingfisher diving vertically towards the water at the rate of 9 meters per second above it. If the refractive index of water is 4 by 3, find the actual velocity of the dive of the bird. ब्रैकेट में किंगफिशर. मतलब ये है एक लेक और रिवर जिसमें एक फिश है. द फिश इज डाइविंग अपवर्ड एंड यहाँ पे एक किंगफिशर है which is diving downward. I again, अच्छा, refractive index of water 4 by 3. Now I again want to read the question. A fish is a fish rising vertically upward with a speed of a fish rising vertically to the surface of water in a lake uniformly at the rate of 3 meters per second. तो ये 3 meters per second से जा रहा है. ठीक है. Observes a kingfisher diving vertically towards the water at the rate of 9 meters per second. 9 मीटर में कौन ड्राइव कर रहा है? किंगफिशर विथ रेस्पेक्ट टू फिश. फिश ने ऑब्जर्व किया. ठीक है. A fish is rising vertically upward to the surface of the water in a lake uniformly at a rate of 3 meters per second. Observe a kingfisher. तो कौन ऑब्जर्वर है? Observe a kingfisher. Fish is the observer. Very good. Kingfisher diving vertically towards the water at a rate of 9 meters per second vertically above it. If the refractive index of water is 4 by 3, find the actual diving of the bird. तो मुझे क्या चाहिए? Velocity of the kingfisher चाहिए, है ना? Is it clear? Velocity of the velocity of the kingfisher चाहिए, and that is the velocity of the fish with respect to kingfisher, है ना? तो ऑब्जर्वर कौन है? फिश. तो अगर मैं इसको S मान लेता हूं, अगर मैं इसको H मान लेता हूं, तो मैं S इक्वल्स टू क्या लिखूंगा? बोलो. जल्दी बोलो. हेलो. अरे इतना टाइम नहीं है, जल्दी बोलो. We do not have all days. जल्दी बोलो. क्या होगा? अरे यार तुम लोगों को कुछ पूछता है तो तुम लोग गूंगा बहरा बन जाता है, जल्दी बोलो। अरे ये कर रहा है ना, अपना डिस्टेंस को सेम देखेगा और इसको क्या देखेगा, ऊपर देखेगा, तो क्या लिखेगा, NH और H/N।
NH.
इतना बोलने में इतना टाइम लगता है। देखो ये है डिस्टेंस, लेकिन क्वेश्चन दिया है स्पीड में, तो क्या करना है, डिफरेंशिएट विद रिस्पेक्ट टू टाइम, ds/dt, dx/dt, n इज कांस्टेंट, dh/dt। अब देखो s जो है फिश विद रिस्पेक्ट टू किंगफिशर जो कि 9 है, dx/dt फिश का अपना स्पीड कितना है, 3 मीटर पर सेकेंड, n है 4/3, निकालना किसका है, किंगफिशर का, सो dh/dt। सो क्या हो गया, 4/3 dh/dt, that is 9 minus 3, 6, so dh/dt that is 6 into 3/4, तो हो गया 9, 9/2 that is 4.5 meter per second. Is it clear everyone?
Yes, sir.
So that's it for today. Okay.